In this video, we're going to continue on with our lecture on functions of several variables, but we're going to talk about level sets. And essentially, this is just a sketch in one dimension lower than the graph is. So if we have a function of two variables here, the output z is a three-dimensional surface, but our level sketch is going to say, well, what if z is a particular value? Then what are the x and y values that correspond to that particular output? And so that's what we're going to be sketching. For three variable functions, we have the level sets f of x, y, z is equal to c. So here what we'll have is a particular c value that is the output of our three variable function. And we want to look at the level surface that corresponds to that output value. So again, here for two variable functions, we will have a level curve. So we'll have a curve in two dimensions, which is essentially the domain that corresponds to a particular output value. And in three variable functions, we'll have a level surface. So our domain now is going to be a surface in three dimensions, corresponding to a particular output value. All right. Why do we even do something like that? Well, clearly it would be hard to draw a four-dimensional object. So in particular for a three variable function, we can't draw a four-dimensional object, but what we can do is we can draw their level surfaces to see a little bit of an idea of what's happening. And for two variable functions, we can usually draw a three-dimensional object, but by hand that's kind of hard. So if we draw a two-dimensional level curve, that is usually an easier way to represent what's happening in the function. So let's go ahead and do that, and we'll see how this works. Okay, so for the following function and values of c, we're going to determine which, if any, of the level sets are empty, and then we're going to sketch and label all of the non-empty ones. So all we have to do here is set c equal to each of these values. Well, what is c? C is our level sets. We replace f of x, y with each value of c. So let's just do these one at a time. Negative 1 is equal to the square root of 9 minus x squared minus y squared. Well, this level set is empty. Now, why is that? Well, we can never have any x and y value. None of those values can possibly make this output negative 1. What about the next one? Let's c equals 0. So c is 0. Well, this implies that 9 minus x squared minus y squared is equal to 0. Or in other words, 9 is equal to x squared plus y squared, which is a circle of radius 3, centered at the origin. Okay, let's go on. Let's check for c equal to 1. Well, this implies that 1 is equal to 9 minus x squared minus y squared, or 8 is equal to x squared plus y squared. So now we have this circle of this with radius square root of 8. And then finally for c equals 3 is the last c value we want to find a level curve of. So we set f of x comma y equal to 3. So we have 3 is equal to the square root of 9 minus x squared minus y squared. Well, this implies that 9 is equal to 9 minus x squared minus y squared, or in other words, x squared plus y squared is equal to 0. So now we want to sketch those 3 level curves that are non-empty, right? We had 4 level curves here, but that first one is empty. So we'll sketch the 3 non-empty ones. Well, these are a bunch of circles. This first one up here is a circle of radius 3. Sorry, that doesn't look like a circle. I did a bad job of drawing there. The second one is a circle of radius square root of 8. So that's just a little bit smaller here. And then we have a circle of radius 0, so that's just the origin. And then this is the circle, or sorry, this is the C value, or the curve. This is related to the curve C equal to 0. This is related to the curve C is equal to 1. And this point in here is related to the curve C is equal to 3. Now, let's actually think about what that means. This is a function, z is equal to square root of 9 minus x squared minus y squared. Well, that is the top half of a sphere of radius 3, right? What does this look like? This is x squared plus y squared plus z squared is equal to 9, except we solved for z, so we subtract x squared and y squared over, and then we take the square root. So this is just the positive, or the top half of the sphere of radius 3. What this is saying is when z is equal to 0, what is the domain that makes z equal to 0? Well, that is the circle x squared plus y squared is 9, so the circle of radius 3. What about when the z value is 1? Well, that's the circle with radius square root of 8. What about the z value of 3? Well, that's just the singular point, x equals 0, y equals 0, that will output 3. And so that's what we've drawn here. That's what these level curves are. Okay, we got one more example here. For the following function and values of c, we're going to determine which, if any of the level sets are empty, and then we're going to sketch and label the non-empty ones. Well, notice here we have a 3-dimensional function now. So now it's going to be a level surface that we sketch instead of a level curve. So we're actually going to be sketching surfaces in 3 dimensions as our domains here. But let's work through these 5 c values. First off, -1 is equal to e raised to the x squared plus y squared plus z squared. When can this happen? Well, never. That is an empty level surface, right? No values of x, y, and z that when we plug into this do we get an output of -1. Similarly, we cannot get an output of 0 either, right? Because e raised to anything is greater than 0. All right, what about 1? Well, if e raised to something is 1, that something has to be 0, so x squared plus y squared plus z squared is equal to 0. All right, we have 2 more here. How about e is equal to e raised to the x squared plus y squared plus z squared? Well, this implies that x squared plus y squared plus z squared must equal 1, which is a sphere of radius 1. And e to the 4th, this is our last one, e is equal to e raised to the x squared plus y squared plus z squared. Well, this implies that x squared plus y squared plus z squared is equal to 4. That is a sphere of radius 2. So let's draw our level surfaces. This is the positive x direction, positive y, positive z. And we have two spheres here. We have a sphere of radius 1 and we have a sphere of radius 2. Not great at drawing spheres, but there's my attempt at a sphere of radius 2. And then we have a sphere of radius 1 as well. And then, of course, we actually also have the sphere of radius 0. So the sphere of radius 0 corresponded to the c equal to 1 value. Then we had a sphere of radius 1 was c equal to e, and a sphere of radius 2 was c equal to e to the 4th. So essentially what we're drawing there is this value, x equals 0, y equals 0, z equals 0. When we plug it into the function, will output 1. Everything on this sphere here of radius 1, when we plug it into our function, we will output a value of e. And if we plug in any value on the sphere of radius 2, our output will be e raised to the 4th power. All right, and that's what we're sketching when we sketch these level surfaces. And that ends this video.